Welcome to another class of computer programming. And today we are dealing with two things. First of all, we'll end the control statements where we'll be doing the jump statements or as you know, these jump statements as break, continue, go to, these sort of statements. And that is the first part of today's lecture. In the second part, we'll have an introduction to arrays, single dimension arrays as well as multi-dimension arrays. But our focus is more on two-dimensional or double-dimension arrays because they are representations of matrices. So in mechanical engineering, we are specifically interested in matrix manipulations, matrix multiplication, matrix inversion, obviously addition, transpose, these sort of things we can perform using computer programs. In order to do that, we obviously need to have a strong base regarding arrays, how to declare them, how to initialize them, and how do you handle arrays in a program. So the introduction to that will be done in today's class. We will continue with this topic of arrays in the next class also. So these two things we are going to cover in today's class. Now, without further delay, let us go straight into the first topic, which is the jump statements. And here, again, we introduce this basic programming structure, which by now should be quite familiar to you. In a few of the previous classes, we have started the lecture with this slide, and we have had a full discussion, quite a detailed discussion regarding the various basic programming structures in C. Here we have the sequential structure, the selection structure, as well as the repetition structure. Now, obviously, in all of these cases, that means these three basic programming structures, there is a normal control flow. That means the control flows from one place to the other, and that is for the sequential structure, it's linear. That means it starts from somewhere here at the beginning, somewhere around here. Then as it is a linear structure, one by one these statements would be executed and it would end somewhere here. Similarly, for the selection structure, the control comes from here. There is a test condition depending on whether it's true or false. One of these two branches will be followed and it will go out from this side. For repetition structure, once the test condition evaluates to true, it follows this circuit, evaluates it or executes it for a specified number of times, that is called iterations. And once it gets a false answer, then it moves out of the loop and to the next statement. So that is what is known as the normal control flow. But in C, you have certain statements which are used to interrupt this normal control flow. These are called jump statements. So what is the objective of jump statements? They are used to interrupt the normal flow of the program. For example, if a jump statement is encountered somewhere here, which jump statement I'm not yet specifying. Let's say one of the jump statements has been encountered over here. So it is quite possible to program flow to jump from there to this nth statement without executing all the statements which are in between. It is also possible to, let's say, jump from here to this place. Now, obviously, this is not the normal flow of the program. We are interrupting the normal flow and making the control go to some other place in this program itself. So that is the interruption. Same things can happen over here or even here. Suppose there is a jump statement inside this that may be used to break the loop and exit it to move the control to this location, to the next statement. So that is the objective of the jump statement. It causes an unconditional jump to another statement elsewhere in the program. So if we have to define it formally, then we say that jump statements are those statements which, when encountered, makes the control jump to another section of the program unconditional. So that is the formal definition. Now, what are these jump statements? C provides us with 4 kinds of jump statements: break, continue, go to, and return. Now, two of these jump statements we have already seen and used in programs. In each and every program that we write, we use the return statement. We use return 0. It is a kind of jump statement. But we'll not be discussing the return statement in today's class. We'll have a look at break, continue, and go to, but return statements will be dealt with when we cover the topic of user-defined functions. That is where we'll talk about this return statement in detail. But here we have the break statement as well. We have also used this break statement previously, although we have not gone into the details of it, but we have used it. Where do you remember? Can anybody tell me? Where we have used the
switch case.
Exactly, the switch case statement used the break statement. That is one of the examples of the jump statement. It has been already used. Similar to that, there are, of course, continue statements and go to statements. Let us look at them one by one. In break, what we do is we terminate the execution of the immediately enclosing loop, maybe a while loop or a do while loop or a for loop, or the switch case structure. So the break statement can be used for loops, any of the 3 loops, or the switch case structure. And its function is to immediately terminate the execution of that loop. What does the continue statement do? It passes the control to the end of the immediately enclosing loop structure. Again, it can be used for all 3 of the loop structures, that is while, for, do while. What is the difference?
Sir, can you give an example? I mean,
yes, of course, we'll give an example. I will show you through a demonstration program as well. But let me explain just a little bit here, is that in break statement, the loop is completely terminated. Say we are inside a for loop, and the for loop is supposed to run for 10 number of times, for example. Now, within this for loop, you have the break statement that is activated, let's say, in the 7th iteration. That means when I is equal to 7, for that iteration, when the control enters the body of the for loop, the break statement is activated. So when that is activated, it will just terminate the loop then and there. It will move out of the loop. The other 3, say, iterations, we are at 7. It was supposed to run for 10 number of times. So 8th, 9th, and the 10th iterations will be skipped. It will not be done. On the contrary, if on the 7th iteration, instead of the break, the continue statement is provided there, and that is activated, then the statements following the continue statement will be skipped, but the loop does not end. So we have had already 6 runnings of this loop, 6 iterations of this for loop. On the 7th, the continue statement is activated, and all those statements that are after the continue statement will be skipped, and it will go to the 8th iteration. So there is the difference. Break terminates the loop, continue does not terminate it. It only skips the statements following the continue statement for that particular iteration. So 1 to 6 will happen. 7th will take place partially because those statements after the continue statement will be skipped. And 8th, 9th, and 10th iterations will also take place. So there is the difference. Obviously, if we show an example of this, it will become much more clear, and we'll do that. Next, we have the go-to statement. This is an unconditional transfer of control to someplace else in the code. You have a labeled statement, and you instruct the code, the program, to go to that level. The hint is in the name itself, name of the command. It says go to. Means that you are instructing the program to go to a specific place. I can tell you to go to the classroom. So you will go to your classroom. Simply, it's an analogy of that the program is told to go to a certain place, and it will go to that place. As you can see here, unconditional transfer of control to a labeled statement where the level identifier is in the scope of the function containing the go to statement. That means you cannot send the control from one function to another function. It has to remain within the same function. But one caution about the go to statement is that this can lead to a lot of problems. And in fact, most textbooks or online teaching materials would advise against using of go to statements. It's very difficult to handle, and it's difficult to understand the program as well, because you can send the program control to any place within the code. It is very difficult to understand how the program executes. So that is why usually go to statements are avoided. Finally, we have the return statement. It terminates execution of a function and returns control to the calling function. It may have a return value or it may not have a return value. You can see that for the main function, we write return 0. That means it does not have a return value. So that is the preliminary discussion about the jump statements. Let us now have a detailed look at some of these statements, starting with the break statement. Now here, the syntax is quite simple. You just write break semicolon. That is the syntax. And if that break statement is encountered, as already mentioned, it terminates the execution of the loop or the switch case statement. It terminates the execution of the rest of the block where this statement is present, and takes the control out of the block to the next statement after the block. Let's look at this. We have already seen this in previous classes while we were discussing switch case statements. So you have the switch expression. Let's say that expression matches with the case 2, that is constant 2. So what will happen? These statements over here are going to be executed. Once all the statements are executed, it comes to this break statement. And once this statement is activated, this is what happens. So it will go directly to the end of the switch case block. Is that clear? Okay. So once it goes to the end, then it will follow on to the next statement after the switch expression. Now let's say we have a for statement, a for loop, and inside this you have this break. So how many number of times this for loop will run is dependent on these three expressions, right? Now, when it is inside this loop, let's say in some uh, iteration, this break statement is activated. Now, break inside a for loop would not be left like this. Otherwise, what will happen is that in the first iteration itself, break is active. It will simply go to the end. So what is done usually is that it is kept inside this sort of a statement. That means, let's say if I is equal to some number n, if that is satisfied, then only the break would be active. Otherwise, all the statements within this loop are going to be executed. So this is how the within the for loop break statement is used. It is same for while statements as well as do while statements. And once it comes to the end of the block, then the control moves to the next state. Now, one more thing that needs to be kept in mind is that break can also be used in nested for loops, which means you have a for here, and inside this for loop, you have another for loop. So if break is here, obviously with the accompanying conditional statement, then it exits from the inner loop only. It does not affect the running of the outer loop. You can see here that for nested loops, it only terminates the inner loop where it is used and not any of the outer loops. Outer loops run unhindered. But use of this break statement in the inner loop terminates the inner loop completely. So at this stage, before we move on to the continue statement, let us have a demonstration of the break statement. So this is the dev C++ platform, and I have already done the preliminary work. This is a demonstration in computer programming class of jump statements, such as the break. So let's start this program, right? Int,
Sir, one thing,
yes.
break statement is really useful when, I mean, I'm telling a specific case in
Mhm.
finding prime number.
Yes, of course, you can use it. When you have
Yes.
checked all the cases, that means you have a number, say n, you need to check till n by 2, right? So when you have gone up to n by 2 and you have not found anything that, uh, any number that which is a divisor, then you can obviously use the break statement and go out of the loop. That is possible.
Yes, sir, that's
Let's first of all have this for loop. By the way, I hope that you have already listened to the lecture, pre-recorded lecture on for loop. If you have any problems regarding that, you can of course raise questions after this demonstration is over. So let's make this very simple. We'll write, we write I is equal to percent %B. We are printing the value of I. What happened? Provided comma. Okay, if you run this, you have this output. Make it more visible. Increase its readability. Provide the new line. So as you can see, it starts from I equal to 0, goes up to I equal to 5. There is no complication in that. But let's say now I have provided this break statement. And this break statement is activated when I is equal to 4. Brackets are not mandatory here because there is a single statement. So I could have just simply put break over there. But let's keep to the syntax and do it like this. So what do you think will happen? At the fourth iteration, it is going to break. So as you can see, it starts with 0, 1, 2, 3, 4, and then 5 is not printed anymore because the loop has been terminated. If I take this and put it after the break statement. Now let's see what happens. How far it has gone? I equal to 3. Why?
Why, sir?
Because before printing this statement, the break statement has taken the control out of the loop and here. How does it operate? When it becomes I becomes equal to 4, then it goes into the loop because this condition, test condition, is satisfied. It is true. 4 is less than 5. So it goes in. If I equal to 4, that is satisfied, goes into this if block. That is the break statement, directly goes to the end of the loop. It does not execute this statement.
Yes, sir. Yes.
Got it? Previously, this was before the break statement. So once I equal to 4 is printed, then only the loop was terminated. Here, the loop is terminated before the printf command is
Sir,
used. Yes.
If I mean in this program, I mean
Mhm.
just as it is, if I use continue instead of break, then it will print 0, 1, 2, 3, and 5, right?
Yes, the fourth case would have been skipped.
Okay, sir.
Okay. Now, if you provide continue after the printf statement, it does not have any effect.
Yes,
We'll
yes.
show it later on. But I wanted to also show you the nested loop. So let's create another loop where j is the index. That also goes from, say, 0 to less than equal to 5, j plus plus, and here we provide this. So we'll cut it out from here, put it inside this. Obviously, this cannot be I, it j. And
Sir, variable define করতে হবে।
yes, we'll go to that. We'll do that. But let me just modify this first. We'll write both I and j. And reduce the number. I runs for 4 times, 0 to 3, and this runs for make it 5 times, and this one, let's make it 2. Okay. And to make it more visible, we'll go out of this, and instead of writing this, just put a line that indicates when one complete iteration has been done. As you pointed out, we obviously need to put the variable here, j. So this is the program. So what we have here is 2
There
for
will be a
loops.
comma
One,
before JU.
okay, it's a dot, is it? Let's replace it with a comma. So what we have here is 2 for loops, one inside the other. That is known as a nested for loop. Nested for loops are quite useful, and we'll see how its usefulness in case of matrix manipulations later on. But let's first of all see how this break statement works. Okay, first of all, let us remove this and see how the program now runs normally. So as you can see, it starts with 0, 0, 0, 1, 0, 2. That is for I equal to 0. It has gone from 0 to 4. For I equal to 1, it's gone from 0 to 4. So I has run 4 times, and inside it, j has run 5 times. So that is how it's going to happen. The new line here.
স্যার পরের গুলো j equals to 0 টা হলো না কেন?
J equal to 0 was there, but it was beside this line, so that was not visible. Let's run it again. Let's see if j equal to 0 is there. There is j equal to 0. It's there. J equal to 0. That is there.
Okay, sir. Okay, sir.
Okay. Now let's get rid of this comment and how do this. I has run all 4 times, 0, 1, 2, 3. But j started with j0, goes to j1. As soon as j becomes 2, break is activated. And it goes out of that inner loop. As it goes out of the inner loop, the outer loop is still active. The loop for I is still active. So the next iteration starts for that. So that is how it runs like this. I hope that is clear. And
Yes, sir.
okay.
Yes, sir.
Let's go back to our presentation. Now we'll look at the continue state. Here, the syntax is again quite simple, continue followed by a semicolon. and it is exclusively used in case of loops. The three types of loops that we know: do while, and for. We have already mentioned in the preliminary slide that instead of terminating the loop, it stops the execution of the statements following the continue statement and goes to the next iteration. So let's show this for loop as an example. We know that depending on the initialization statement, the test expression, and the update statement, this loop is going to run for maybe n number of times. Now, within this body of the for loop, there is this continue statement. And again, usually the continue statement would be embedded inside a conditional check. A conditional statement would be there. That means if, let's say, I is equal to uh, say some number of iterations, then only the continue statement would be active. The program flow will go inside that condition check, conditional block, and execute the continue statement. If continue statement is executed, what happens is this: those statements that are immediately after the continue statement, that means these statements, they are skipped, and control comes here, but it does not flow to the next statement after for, because the loop is not over yet. The loop is not terminated. Only these statements after the continue statement has been skipped. So from here, it goes back to the beginning of the loop and it starts to execute again. So that is how the continue statement takes place. In this case also, if there is a nested loop, the continue statement passes the control to the next iteration of the inner loop where it is present and does not affect the running or execution of the outer loop at all. Let me just create another file here. I'll take the shortcut and do a copy paste. Not advisable, but anyway, let's do it to save time. Let's save it as a C source file. Break is there. Let's save it as continue.
Sir, can I leave the class for 2 minutes? Actually, one teacher is calling me. Can I attend?
Sure, sure. Okay, you can.
Okay, sir. Thank you, sir.
Okay, so let's say first of all we take the simple example. I have this, not have this. Let's remove that. That is also not there. This is also not there. So in this loop, what we have is for runs from 0 to 3, that means 4 number of times. And in the third iteration, that means 0, 1, 2, that is the third iteration, you have this continue. J is not there. Let's so you can see that I equal to 0, I equal to 1, I equal to 3. Where is I equal to 2? That is the statement which has been skipped. Inside this loop, when I becomes equal to 2, it goes inside the if statement. There is this continue. As it encounters this continue, it goes from here to the end of the loop. That means this statement is skipped. it will go back to the next iteration. That means go back to the start of the loop and commence the next iteration. However, if we had provided this before that, there is no statement after the continue, isn't it? So in that case, what will happen that there would be no difference. That means the continue does not make any difference to the running of the loop. You have all three, all four, as I should say. So I equal to 0, 1, 2, 3, all are there. Why is that? Because this continue statement is activated after the printf has been executed. So there is nothing after this loop. So there is nothing to be skipped. So you should always keep in mind that you cannot use the continue at the end of the loop. It does not have any effect. Let's see for a nested loop how the continue statement affects the execution. Now we take this and put it after the loop. I have put I here. This needs to be J. This is J. Okay, let's save this. Now run it. And you'll see that in each of these cases, it goes 0, 1, 3, 0, 1, 3, 0, 1, 3, like that. So in each of these cases, j equal to 2 has been skipped. So that is how the continue statement affects the inner loop, but it does not have any kind of effect on the outer loop. So that is the working of continue statements. Let us now go back to our presentation. Any questions up to now?
No, sir.
Okay. Now we have the go-to statement. As already mentioned, it affects an unconditional transfer of control to a leveled state. Syntax is go-to and then the identifier, the level. Now it could be anything. Let's say we take a look at this example, and you can see that here you have this statement level, then you have a colon, then some statement, generic C statement is present. There is the go to. What it says, go to level. You are instructing the program to go to this level. It will find out where this level is and it will take the execution to that line. So this is what happens. This is known as a backward jump. It is going back in the program. Similarly, a forward jump can also be done. You can see that here we have go to level at the beginning, right here. So the program would search for this level. It will find it here. And the execution goes. So this is known as a forward jump. Do notice that all these statements are not executed because of this jump. Executions come from this side, finds out the go-to statement. There is this level. It jumps to, it makes a forward jump to the identifier and its corresponding statement, and then moves this way.
স্যার তাহলে তো মানে আরো মানে ওই গোটু এর মাঝখানে স্টেটমেন্ট গুলো হয় রিপিটেডলি ওয়ার্ক করতেই থাকবে আর নয়তো কখনোই ওয়ার্ক করবে না।
Exactly. That is why this go-to statement is not preferred. If you do not handle this go-to with adequate amount of care, this is going to lead your program haywire. It's going to cause problems. So
স্যার
be
কেটে যদি
very
লেভেলটা আমি এরকম দিই যে স্টেটমেন্টটা একটা টাইমে ধরে নিন আমি লিখে দিলাম i is less than 3, এবার যতক্ষণ 3 স্টেটমেন্ট আসছে ততক্ষণ লেভেলটা
yes, of course. That's what I mean by appropriate care. You have to, you do not use this haphazardly. Okay,
সেটাই।
you have to think about the pros and cons of using it in a particular location in this program. For example, as you mentioned, if I just put this go to level and this level statement, there's nothing else. There's no if statement, there is no conditional check, there's nothing. What will happen? It falls in a loop and it will never come out of this loop. These statements, which are in between the level and the go to statement, it will be executed infinitely. So there is a problem here. You cannot use it like this. However, if you take proper care, then obviously go-to can be useful. Take this for an example. This is from a previously demonstrated program. If you can remember, towards the beginning of this course, we had written a program for calculating the area of a circle, area and perimeter of a circle, most probably. So the input was the radius of circle, and based on that, you had calculated the area. Now here, we have also discussed this, that if the user by mistake provides a negative value, then you need to install this check over here so that your program actually works properly. That is why this if statement is provided, that if radius is less than or equal to 0, then you print an error and give a statement that the radius should be non-negative and non-zero. But you can also think about giving another chance to the user. Maybe he has made a genuine mistake. So you do not terminate the program at this, but you put in this go to statement and you say that go to input. Input is the level. So what happens? It will go to this input. It will execute the printf statement again. It says enter the radius of circle. So now, hopefully, the user would provide a positive value for a radius and your program would be executing appropriately. So this is how goto can be used in a useful manner. You can also make this in such a manner that the user is given 3 chances. You can put a counter here. For each of the time this radius is less than equal to 0, you increase the counter by 1. And if it goes to 3, then you can terminate your program. So that is how goto can be used in a program. But again, my advice is that if you are not sure about it, do not use goto. Try to avoid this. Creates a lot of problems. So that brings us to the end of the first half of our lecture. That was jump statements.